Jai Jendra, Namaste and welcome to my channel. Today we are going to solve the 58th question of the problem solving series and the second question of recursion. So the difficulty level for this question is medium, and this question has been asked in Amazon, Facebook, Google, Apple, Microsoft, etc. So we have discussed in the 57th section. This is a similar problem. In the previous question, we needed to find the sum of all subsets. Now here we need to find all subsets. Okay. So finding all subsets of array, that means we need to find the power set, right? We discussed in the previous question the power set. So here when this is the subset, so when this is an array that has been given, so we need to find all the subsets. So the subsets are all the power set. So that is 0, 1, all the possible subsets. 2, 3, 1, 2, 2, 3, and 1, 3, and 1, 2, 3. So how many power subsets are there? 1, 2, 3, 4, 5, 6, 7, 8. So we know the number of subsets possible is always the number of elements. Say, so if n is equal to 3 here, so the number of subsets will be to the power n, that is to the power 3, 8. Okay. So we need to find all the subsets. So in the previous question, I have discussed about one of the important concept of recursion, that is pick and not pick, or take or not take. Okay. Similarly, we will solve this question using the same concept. We know how do we solve. There are 3 steps that I taught you to solve any kind of recursion problem. What were the 3 steps? So 3 steps were: find base case. Okay, first we will find the base case. Second, it was find relation between problem and sub-problem, and then generalize the relation. Okay. So what would be the intuition here? We'll solve it similarly. So any number of elements are given. Say we'll consider this example. So while finding, when we start with 1, we will have an vector of vector. As you can see here, the input is vector of vector. So in this vector of vector, we will insert all the subsets. So all the subsets should be a vector, right? So we'll have a vector and we will decide whether we take this element or not. So if we take it, and then we can move forward and decide we would take it or not. So we'll have that 3 stack space. You please watch out my previous video if you have little doubt about recursion. I want to explain the recursion in details there. So I'll discuss the solution here directly. Okay. So this is the similar question, right? We need to find all the subsets. So here, but there will use a logic called backtracking. Backtracking is we'll solve few questions of backtracking as well. We will use the little bit logic of backtracking. What is backtracking, right? So I'll explain you in this question. You'll understand what is backtracking. So whenever we are going in a path, and then when we come back, okay, so we perform some action, and then that action is taken into consideration in our recursion, and then we remove that action again, right? So for example, here, say if we take this one in our array, okay, in our array we take this one, and then we move to 2, okay. So here also we can take 2, but if, one second. So here we took 1, and then if we take again 2, right, then we will have both 1, 2, but in one of the possible subset we don't want to take 1, we only want to take 2. So there we can use the concept of backtracking. Without backtracking also we can do this, but we'll do using backtracking. So what we will do, we will go back to, so once we have taken this one, then we will call our recursion. But to remove this one, we will remove this, we already have a subset. We will again, before pushing this one to the vector, after getting it into the recursion, we will pop this one, okay. So you'll understand, once I code this, you'll understand. So what we do, I'll just code it directly. Vector of int, vector of int, and say we took a result, okay. And then vector int, we took a subset, okay. Now what we do, we call a function subset util. We will pass the array and the result array. We will pass the subset, and we will pass the index. Okay, what is the index? So int index is equal to 0. Okay, we will pass this, or we can pass directly 0 also, same thing, and then the subset util will give us the result. So we will return result. Okay, and now we will code this subset util. Okay, so what does subset util do? Vector of, so it will be a void call. We will have this as a void subset util. Here we will use backtracking, you will understand once I do complete it. So we'll have this, say, I just write the functions. Okay, array result subset and index. Okay, so here actually 0 is passed, so to make you understand here, 0 is passed. Okay, so in the beginning only we will push the subset into the result. Okay, so that whatever we need to print this, right? So the subset is empty, that's why we will push this empty thing to the result vector of vector. Okay, so subset is done here. Now we will use a loop for I equal to index index I less than array dot size and I plus plus. Here what we will do, we will push this index element to this subset. Okay, so subset dot pushback array array I. Okay. So once we have pushed this, and then what we'll do, we'll call this subset util again. We have this one, and we'll increase the index. Okay, so what is the order? Array result subset and index plus 1. Okay, so here the base case is actually this part itself. This loop will end. Okay, so when I'll explain you backtracking, you will understand this more clearly. I will solve 5-6 questions or 4-5 questions of backtracking. So for now, just keep on going. You'll understand. I'll dry run this, and then we will pop back the subset here, and then we will exit this, and this is done. Now how this code will give us the power set, that is the doubt, right? So now you see here, when we have added this result, so in the first place what will happen here, this 1 2 3 is there. Okay, so in the beginning the result is added, so empty array has come, we have not taken anything, and here we have included the first element. Okay, so here in the beginning we have included 1. Then what we do, we call this again. So when we call this again, you see we pass the index plus 1. So again when it will go, this result will have 1. So again in this vector we have a vector 1. Okay, and now this here again we are calling index plus 1. So and then when again index plus 1 is called here, so this again this will be called here, and result will be pushed. Before pushing we have pushed 2 also. So now our vector will have 1 2. Again same thing will happen, our vector will have 1 2 3. Okay, right? I have coded this, I have this. So okay, I'll write it here. Okay, so nothing is there, 1 is there, 1 2 is there, 1 2 3 is there. So once 1 2 3 is there, okay, our index has crossed this. This is the first part. Okay, now this will pop the 3. So when 3 will be popped, our subset will have only 1 comma 2. So we have excluded now. So so this is the backtracking logic. Okay, backtracking. So we have included and then we have excluded after pushing it. So once this is called, 3 is done. Again, once 3 is done, but then again this cannot be called here. Why? Because if this is called here, again if we call this function array result subset index plus 1. Okay, so again this result would be pushed, but this index plus 1 is actually crossing this, right? So in the next one, it will go up to here only, 1, 2, 3. It can't include this part, right? Because array dot size is, so the index is equal to array dot size. So here this will be finished. So once this will be finished, and we will go back recursion, right? Once your function is done, you have performed the below part. So the result goes to the upper part, right? Stack. So after this is done, so 1, 2, 3 is done, here we are popping this out. So now our subset becomes 1, 2. And then this part, when this part is done, this result will go to the previous part, the function which called it. And when the function which called it was there, so for 1, so the result would be for that 1, 2, again 2 will be popped out. So the result would be 1, okay. And then, or 1, 2, the loop is not completed actually. So again this loop will execute, okay. And when the loop will execute, that point of time our result vector will have only 1, 2 as the subset. So after 1, 2, 3, so 1, 2, 3 is done. So actually the 3 is done actually, right? The array dot size has reached. So believing on the leap of faith, what it will happen? So 1, 3 would be done. 3 would be popped out. It will have only 1, 2. And when 1, 2 is there, then again this 2 will be popped out. So only 1 we will have. And then the 2 would be removed. And our loop would be 1, 3. Similarly, we will get 2, 3 and all the elements with this backtracking logic. Okay. So I hope this is clear. We will discuss this in more details when I will solve rat in a maze and ant queens problem. For now, I think you have understood the solution. I have generalized it. So yeah, the link to the question is given in the description. Please try it yourself and then come to my code walkthrough session. Here is the code walkthrough of the 58th question and the second question of recursion. Return all possible subsets, the power sets. But here in the question it's given the solution must not contain duplicate subsets. Okay, so that means if here in this example, if you see 1, 2, so 2 is repeated. So we will not have the repeated part again. That means you can see here 3, 4, 5, 6. There are only 6 elements. So when we see the elements, the numbers are repeated. For example, 1, 2. This 1, 2 also is there, and the first and the third 1, 2 both are there. So we will include only one subset. Okay. So let's look at the code. It's okay. This question has been asked in already. I've shown you the companies. So this question is a common question. You can see asked in a lot of companies. So look at the code here now. So as I've discussed here, we have there's a little difference in the code. So I'll show this. We can pass it in any order. So he has shorted it just for the sake of a better understanding result. Okay, so we have the vector and we have the result answer, and then we short this array which is nums here, and we return this call this subset recursive function. In this subset, what we do, we insert the vector into the array answer every time, and then we run the loop, and we here in this part of the logic you can see what we do when I is greater than index. Okay, so for the first element it's not going to be repetitive, but then the second element, if it is a repetitive element, okay, so when the I is greater than the index, when we are running it again, and we check that nums I is equal to 1, I minus 1. If the previous element is same as the current element, then we don't go through this code. Okay, we continue it. Okay, so here in this space we push the element, and then we call this subset again. Okay, and then we backtrack by removing the pushed element, okay, from this current vector. Okay, so this recursive function helps us to find the subsets and removes the duplicate. Okay, so we will run this. We have already discussed the solution. Okay, you see the solution has been the test case has been accepted, so we will submit this. So it has passed. I hope the explanation is clear. You will understand it better when I discuss the topic backtracking. Backtracking is one of a difficult topic. I will explain backtracking topic at the end maybe. So after the recursion, I will start with linked list or string. So we will understand this backtracking topic. So I think this is clear. The way we have used backtracking is clear, and see you also in the next video. We are explaining the third question of recursion and the 59th question of the problem solving series. Jai Jinendra.